Hello and welcome, and yeah, my name is Imad, and we are continuing our discussion in organic chemistry. So in this lesson, I'm tackling a few important definitions, and that is namely the following definitions, as you can see over here. We will tackle the definition of a functional group, as well as the definition of a homologous series, right? And then I'm going to talk about two other things, such as saturated as well as unsaturated compounds. That will form one thing and that will form another. So that's what we're going to tackle, more or less, and let's see what we can see a functional group is. Right, so when we start thinking about a functional group, we can say, well, a functional group is really a specific group of atoms. A functional group, yes, is a specific group of atoms within a molecule. In fact, it can even be one atom or group of atoms, or even a type of bond that will form a functional group, right? So the same functional group will undergo similar or the same chemical reactions regardless of the size of the molecule it is actually part of. And that is the group that is really responsible for the characteristic chemical reactions of those molecules. Okay, so when we think of a functional group, we can say, well, okay, if I'm talking about something like the alcohols, and I look at a molecular formula, the structural formula of, let's say, methanol will look like this: C bonded to O, bonded to H. That's hydrogen. And then I've got hydrogen, hydrogen, hydrogen. This here is actually methanol. So the functional group here is the hydroxyl functional group, which is this thing over here. It is the O bonded to H that will give it its characteristics, right? It is that over there, right the way you see it. Let me just take some of that out. There we go. That's the functional group, right? And now, any molecule that has this particular oxygen bonded to hydrogen in this manner, this hydroxyl functional group, is representative of a homologous series known as the alcohols, right? So when we talk about the group of molecules, we consider that the alcohols, and if we look at the actual structural difference, the actual atom that you see over there, you will find that that is the hydroxyl functional group, right? And in a moment we'll see a little bit more examples of this. I've actually jumped ahead by speaking about homologous series, right? But anyway, so let's just quickly recap that. A functional group, in organic chemistry, we find that the functional group is a specific group of atoms within a molecule. And then you can even say it can be even one atom, or it can be a specific group of atoms like we have in this case, or it can even be a type of bond, like the double bond or triple bond that we will see in a moment. And if that sounds foreign, don't worry too much. Okay? And these types of structural changes, these groups of atoms or even the bonds, these are the things that are responsible for the characteristic chemical reactions of those molecules. In other words, it's responsible for the way that these molecules will react with one another and other molecules, of course. Right, so on the next page, let's talk about a homologous series. So the definition of a homologous series, that is the group of compounds that contain the same functional group. It is the group of compounds that contain the same functional group, and therefore they may be represented by the same general formula. So let's take a look at a few different homologous series and their different functional groups. Okay, so while we haven't covered this in detail, we can say that, well, you may have heard in school about this molecule. Okay, the handwriting is atrocious at the moment. Let's just see what we can do over there. Right, this here is actually called ethanol. It's called ethanol. And if I had to say this thing over here, This is a molecule over here, and you can see some things look different and special about these molecules. They're not ordinary simple organic compounds where you just see hydrogens and carbons and that's it. They're not just hydrocarbons. In fact, there are certain molecules, and this one over here is 1, 2, 3, 4. This is butan 2-one or 2-butanone. It's got two names. You can give it either or, 2-butanone or butan 2-one. Right, so let's talk about each of them. Well, what's special about this? Well, the first one has got this thing over here. It's O bonded to H. That oxygen bonded to that hydrogen over there. And this one, it looks a little bit different from that one because this one has got this double bond O. In fact, let's just, oops, let's close that again. Let's just get that entire piece over there. Right? So that's ethanol, and this is 2-butanone, butan 2-one. What is special about them? Well, if you look at these actual groups of atoms in the molecule, we can say that that O bonded to H is the functional group, right? And any molecule with this functional group, that would be called an alcohol. So the alcohol is the homologous series, while the O bonded to H is the actual functional group. Oops. Let's just get the whiteboard back there. Right. And then in this case, whenever we see something like a carbon in the middle bonded to oxygen, right, and this continues over there, and you see this thing over here, this over here is the functional group of a certain set of molecules. Now, any molecule that has got this functional group, in other words, a carbon bonded to an oxygen, that we find somewhere in the middle, right? Not on the end, not there, but rather in any one of the middle carbons in a long carbon chain, then we can say that that belongs to a group called the ketones. Right, it belongs to a group called the ketones, and that there is the homologous series. It is the ketones. So if I had to ask you what type of molecule this is, you're going to tell me, well, Imad, it's got a double bond O, bonded to it's got a double bond oxygen, bonded to carbon in the middle, and so you're going to say, well, that's a ketone. So the homologous series, any molecule that's got an oxygen bonded to a carbon in its chain, in its main chain, somewhere in the middle, that's a ketone. Likewise, if we have a carbon bonded to oxygen bonded to hydrogen, this OH, that is the functional group, and it's actually got a name. It's called the hydroxyl functional group. Okay, over here this is called the carboxyl functional group. Sorry, carbonyl functional group. Right.